All right, here are the notes for section 8.5a for exponential algebra. Our objective today is to factor trinomials that have the form 1x squared plus bx plus c. We will be learning other factoring techniques, but for today we are strictly looking at the ones where our leading coefficient or that coefficient of x squared is just a 1. Before we start the factoring process, we need to review foiling. Remember, foiling stands for first, outside, inside, last. So to get our first term here, we took the first element or term in each binomial and multiplied them together. So x times x gives us the x squared. Then we multiplied outsides, so the x times the 7, and we multiplied insides. So we had 7x and insides 3x. And then because those are like terms, we added them together. So we can add the 7 and 3 to get our 10x in the middle. And then our last term is the 3 times the 7 to give us the 21. All right. The coefficient here for x squared, again, is just going to be a 1 today. And if you look at the numbers, there's a reason we've reviewed foiling, because factoring is just the reverse process. So if we look back at our numbers here, we have a 10 as our middle term, and we had a 21 as our last term. And the relationship between those numbers, if you look back at our factors here, we have a 3 and a 7. And 3 plus 7 would give us 10, and 3 times 7 gives us 21. So when we factor something, we're looking for two numbers that multiply to be our last term, this 21, and they add up to be the middle term, the 10. All right, so in your statement here, notice that the numbers which when multiplied equal the last term, and they also add up to the middle term. All right, so we are going to just reverse the foiling process. This is called factoring. All right, so our first example we said was that x squared plus 10x plus 21. So we start out with our x squared, and we say, what two things can I multiply together to get x, or to get x squared? And that would be an x times an x. The second step is to look at this 21. What are the factors of 21? And we can list them out. We have 1 and 21, or 3 and 7. And then we ask ourselves, which pair adds up to our middle term, which is a 10? And that would be the 3 and the 7. So that's what goes in our factors here, a positive 3 and a positive 7. And remember, we can check that simply by foiling it out. So if we took x plus 3 times x plus 7, first times first there gives us an x squared. Outsides, we have 7x. Insides, we have 3 times x. And last, we have 3 times 7. And combining our middle terms, because they're like terms, 7x plus 3x is 10x. And so you can see that we get back to where we started in our check process. That's how we can know that we factored it correctly. So to factor a trinomial of the form x squared plus bx plus c, you must find two numbers that have a sum of b. All right, they have to add up to that middle term, and they have a product of c. Product meaning multiply. All right, so they have to add up to the middle term, and they have to multiply to be the last term. All right, let's look at a few examples. We have x squared plus 8x plus 15. So again, we can split up our x squared into x and x right away. And we know that when we FOIL, we're going to get that x squared back. Then our next step is to focus on the 15. All right, we look for numbers that multiply to be 15. In other words, what are the factors of 15? And our options are 1 and 15, or 3 and 5. Then we say, which one adds up to 8? and that would have to be the 3 and the 5 option. So we need a positive 3 and we need a positive 5. It does not matter if you put the 5 first in the first parenthesis or if you put the 3 in the first parenthesis. You just need both of them. And then remember, you can check your answer simply by foiling. Okay, let's try another one. We have r squared plus 11r plus 24. So our r squared automatically we break apart into r times r. And then we want factors of 24. There's a few more factors of 24 than in our previous example. We have 1 and 24, we have 2 and 12, we have 3 and 8, and we have 4 and 6. All right, so we're going to look at those pairs and say which one adds up to 11. Well, if we add this first one, we get 25. If we add the 2 and 12, we get 14. But 3 and 8 would add up to be 11. So that's the pair we need, a 3 and an 8. All right, we're going to come back to these two questions here in just a minute. Let's go on to our next page here. In the first couple examples, our middle term was positive and our last term was positive. In other words, our whole polynomial has positive or plus signs in it, and so we didn't really have to worry about any options with our factors. Everything was positive. But what happens when the middle term is negative? All right, we're still looking for numbers in this case that multiply to be 24, but now they have to add up to be a negative. So if you think about how you multiply to get a positive number, like this positive 24, you could either have two positives or you could have two negatives. And for us to get a negative in the middle when we add, we are going to need the two negative version. So when we list our factors of 24, since our C term there is positive and our B term is negative, our middle term, we need to have two negatives. All right, so factors of factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Or we could have both of them be negative. And since we said we need two negatives, we're going to look at this option. All right, so we have four different options where all of our numbers are negative. We still want them to add up to be negative 11, which means we're going to need this pair. All right, so we would factor this into x minus 3 and x minus 8. All right, let's go back to those previous examples and check those out again. All right, it says, what is the factored form of y squared minus 6y plus 8? All right. So again, because we have a positive here, when I multiply, I can have two positives or two negatives. Since I need a negative here, that tells me I need the two negative version. All right, so I'm going to list factors of 8, but have both of them be negative. Like negative 1 times negative 8 would be positive 8. Negative 2 times negative 4 would be positive 8. And this is the pair that adds up to my negative 6. So my factors are going to be y minus a 2 and y minus a 4. And remember, you can always check these by foiling them out. All right, the second question says, can you factor x squared minus x plus 2? So again, noticing the signs, here to get a positive when I multiply, I need either two positives or two negatives. But to get the negative in the middle, I have to have the two negatives. So factors of 2 where both numbers are negative would be negative 1 and negative 2. That's my only pair. But when I add this, it adds up to negative 3, which is not what I want in my middle term. I wanted a negative 1x squared. And since I can't get that with the factors that I'm given, this is not factorable. All right, so let's go back and try a few more examples here. It says factor each trinomial. If it is not factorable, write not factorable, or you can write the term prime, means the same thing. All right, so our first one, x squared plus 11x plus 24. We've done this one in our notes already. We break apart the x squared into x, and we look for numbers that multiply to be 24, like 1 and 24, 2 and 12, 3 and 8, or 4 and 6. And then we need them to add up to 11. So 3 and 8 is going to give us that 11. Okay. Our second one, we need to split up our x squared, x and x. We need factors of 24, which we've already listed, but this time we need the middle term to be negative. So to make that happen, we need negative numbers for both. Still multiplies to be positive 24, but it does add up to a negative value. And we're looking for a pair that adds up to negative 9. So we start out negative 1 and negative 24, that adds up to negative 25. Negative 2 and negative 12 adds up to negative 14, that doesn't work. Next pair adds up to a negative 11, and the last pair adds up to negative 10. There's no way I can get this negative 9, so we say it's not factorable. Or we could just say the word prime. All right, example 3. We can break apart our x squared into x times x. When we FOIL that out, our x squared will come back. Factors of 12 are 1 and 12, 2 and 6, or 3 and 4. And the pair that adds up to the 7 in the middle would be the 3 and the 4. Okay, question 4 is very similar, except it has an extra variable on the end. So if you think about how we took this x squared and we split it up to have an x in the front of each parenthesis, we're going to do the same thing with the y. We can take our y value, this y squared, and we can split it up into a y in each one. All right, and then we're looking for factors of 2. Well, we only have one pair, 1 and 2. 1 times 2 is 2, and 1 plus 2 is 3. So it is going to work to add up to the middle number that I need. So I have an x plus a y and an x plus 2y as my two factors. All right, question 5. Again, we split up our x squared into x and x. We need factors of 48, and there's a few more of these, so I'll put them down here. Factors of 48, we could do 1 and 48, we could do 2 and 24, we could do 3 and 16, 4 and 12, and 6 and 8. All right, we're trying to get a negative in the middle, which means instead of the 2 positive version, we need 2 negatives. All right, again, they multiply to be positive 48, but they would add up to be negative 16. So we need to think of all of these as being negative. And the pair that adds up to negative 16 would be this negative 4, negative 12 option. Okay, and our last one goes back to having multiple variables again. So we're going to split up our y squared in the front to be y times y. We're going to break apart that z squared and put 1 in each one at the end. And then we're looking for factors of 6. So 1 times 6 or 2 times 3. And the pair that adds up to the middle number 5 is the 2 and 3. So we have y plus 2z and y plus 3z. Now it says check your answers, and remember we do that by FOILing. So let's just check this last one that we just did. We have y plus 2z times y plus 3z. All right, FOILing it out. We take first times first. So y times y would be y squared. Outsides to outermost terms. So y times 3z is 3yz. And then inside, 2z times y would be 2yz. And our last term, 2z times 3z would be 6z squared. And when we combine these two terms in the middle that are like terms, we end up with y squared plus 5yz plus 6z squared, which is what we had originally as our question. So we did factor it correctly because we can FOIL our answer out and get back to our original question. All right, take a few minutes and write down your summary, and then your homework tonight is worksheet 8.5a.